For decades, coding has been unforgiving, demanding precise syntax, logic, and intricate details like perfectly placed semicolons and brackets. Missing a single element meant the computer would fail to execute the program. That meant only specialized engineers could actually make stuff on the web. Anton Osika believes this era is over. He lives in a collective house in Stockholm. He does not look like the founder of a billion-dollar AI startup. There are no black turtlenecks. There are no polished, rehearsed speeches about changing the world. Instead, there is a quiet intensity. He is a physicist by training. He is a builder by necessity. His latest creation is called Lovable. It is a piece of software that writes software. It allows anyone to describe an idea in plain English and see it manifest as a functioning application in seconds. It is the fastest-growing startup in the history of Europe. This is the story of a man who made that possible. A story of how Lovable became one of the fastest companies globally to hit $100 million in annual recurring revenue and a unicorn. If you have never heard of it, know that this is the company on whose platform more than 10% of all new websites globally are being made. Anton Osika was born in Sweden in 1990. The 90s were a time of transition. The analog world was yielding to the digital one. For young Anton, the world was a puzzle to be taken apart. He dismantled gadgets. He needed to know what lived inside the plastic shell. He needed to see the green circuit boards and the copper wires that carried the invisible signals. He watched The Matrix as a young boy and saw a vision of a world constructed entirely of code. It was a fiction, but it planted a seed of truth. The digital world was malleable. If you knew the language, you could bend the rules. You could change the physics of the simulation. At 12 years old, he went to the library. He taught himself to code using books that were likely dry and technical, yet utterly fascinating to a mind looking for control. This was the first step. Code was just a tool. The deeper question was about how the world worked at a fundamental level. Code governs the computer. Physics governs the universe. Osika followed this question all the way to the Royal Institute of Technology, or KTH, in Stockholm. He enrolled in engineering physics. This is one of the most rigorous programs available at Sweden's top engineering college. In high school science, we learn that the world is made of atoms. We learn that force equals mass times acceleration. It is a deterministic world. If you roll a ball, you can calculate where it will stop. But as you go deeper into physics, the certainty vanishes. You enter the domain of quantum mechanics. Here, nothing is certain. Everything is a probability. An electron is not a point in space. It is a cloud of potential. It might be here. It might be there. You cannot know until you measure it. This training rewires the brain. It teaches you to think in models. You stop seeing the surface of things. You start seeing the underlying equations. When Osika looked at a complex system, he saw beyond the chaos. He saw parameters and variables. He saw a system that could be optimized. He considered a career in research. He traveled to Switzerland to work at CERN. CERN is the cathedral of modern physics. It is home to the Large Hadron Collider. This is a machine that spans 17 miles in a circle, buried beneath the border of France and Switzerland. It smashes protons together at near light speed. The goal is to break them apart and see what comes out. At CERN, the challenge is not just the physics, it is the data. The collider produces millions of collisions every second. The amount of data generated is astronomical. It is of the same order of magnitude as what Google or Facebook handles in a year. No human could look through it. No team of humans could look through it. They need algorithms. They need software to sift through the noise and find the signal. They need to find the one event in a billion that reveals a new truth about the universe. Osika worked in this environment. He saw how machine learning could take a chaotic stream of information and find the pattern. But the pace of academia is measured in decades. You build an experiment. You wait years for the machine to be upgraded. You gather data for another few years. You publish a paper. It is a slow and deliberate march toward truth. Osika wanted something else. He wanted impact. He left the path of academic research. He took the skills of the collider and applied them to the code. Anton Osika joined a company called Sana Labs as their first employee. The year was 2016. The world of artificial intelligence was beginning to wake up. Sana Labs was a pioneer. They wanted to use artificial intelligence for education. The goal was to personalize learning. If you are learning a new language or a mathematical concept, the computer should know what you know. It should know what you do not know. It should predict what you are likely to forget. There are two main ways to do this. The first way is called collaborative filtering. This is the method of looking for similar users. If Alice likes apples and bananas, and Bob likes apples and bananas, then if Alice likes cherries, it is probable that Bob will like cherries too. It relies on the wisdom of the crowd. The second way is content-based filtering. This looks at the item itself. It looks at the apple. It sees that it is a fruit. It sees that it is sweet. It sees that it is red. It recommends other things that are fruit, sweet, and red. Osika built these systems at Sana. He honed his skills in machine learning. He learned how to take the theoretical math of KTH and turn it into code that ran on servers and served real users. He learned the difference between an algorithm that works in a lab and a product that works in the messy real world. It was during this time that he met Oliver Edholm, a fellow prodigy in AI. Edholm's background was notable. He dropped out of high school at age 15 to pursue AI research at Klarna, a fintech unicorn. Recognizing a shared opportunity, the two turned their attention to the world of commerce. The giants like Amazon had massive teams of engineers building their recommendation engines. They could predict exactly what you wanted to buy. But the smaller stores were flying blind. They did not have the data. They lacked the engineering talent to build these complex brains. They were losing. Osika and Edholm founded Depict.ai in 2019. The premise was simple. They would build a brain that any store could plug into. They would democratize the power of the algorithms used by the giants. They would use deep learning to understand product images and descriptions. The AI at Depict was designed to see. It would look at a picture of a dress. It would understand the style. It would understand the cut. It would understand the fabric. It would not just match keywords. It would match the vibe of the product. Depict.ai was a success. It grew rapidly. It attracted the attention of the world's most prestigious startup accelerator, Y Combinator. Y Combinator, or YC, is based in Silicon Valley. It is the Harvard of the startup world. It has birthed companies like Airbnb, Dropbox, and Stripe. To get into YC is to be anointed. You move to California for 3 months. You live and breathe your product. You are mentored by the legends of the industry. Osika and Edholm were accepted. They went to the mecca of tech. They raised money from top-tier investors, including Tiger Global and EQT Ventures. They built a team. They scaled the company. Osika served as the Chief Technology Officer, or CTO. He was in the engine room, ensuring the AI delivered on its promise. This experience was vital. It taught him the Silicon Valley playbook. It taught him about scaling. This is a term that describes the process of growing a company exponentially. It is not about adding 10 customers a month. It is about adding 10% every week. It requires a different kind of physics. It requires overcoming the friction of organizational drag. But even as Depict flourished, Osika felt the pull of a new wave. The year was 2023. The world of artificial intelligence was undergoing a phase transition. For decades, AI had been about analysis. It was about classifying data. Is this email spam? Is this image a cat? Will this user buy this shoe? Now, AI was learning to create. The shift began with a paper from Google researchers in 2017 called "Attention is All You Need." It introduced a new architecture for neural networks called the transformer. Imagine you are reading a sentence, "The cat sat on the..." Your brain naturally wants to fill in the blank. You know the next word is likely mat, or floor, or sofa. you know it is unlikely to be sandwich or democracy. Your brain assigns probabilities to the next word based on the context of the words that came before. The transformer architecture allowed computers to do this with unprecedented skill. It allowed them to pay attention to the entire context of a sentence, a paragraph, or a book. It allowed them to understand the relationship between words that were far apart. This led to the creation of large language models, or LLMs. These models were trained on the entire internet. They read every book, every article, and every line of code that had ever been published online. Code, after all, is just a language. It has a grammar. It has a syntax. It is much more structured than English. If an AI could predict the next word in a poem, it could certainly predict the next keyword in a function. Osika saw this. He saw that the barrier to entry for coding was about to collapse. He saw that the role of the software engineer was about to change from a bricklayer to an architect. He began to experiment. He created a tool called GPT Engineer. It was an open-source project. Open source means the code is free for anyone to see, use, and modify. He put it on GitHub, which is the library where developers store their work. The promise of GPT Engineer was bold. You could tell it what you wanted to build in natural language. Build me a snake game, build me a to-do list app, and it would generate the entire code base. It would write the files. It would structure the project. The response was electric. The project became one of the most starred repositories on GitHub, gaining over 50,000 stars. A star on GitHub is like a vote of confidence from a peer. It means other developers find your work useful. To get 50,000 stars is rare. It placed GPT Engineer in the pantheon of legendary projects. It was a signal. The world was hungry for this. Developers were tired of the boilerplate. They were tired of setting up the same structures over and over again. They wanted to focus on the idea, not the plumbing. Osika realized that this was not just a side project, this was the future. In late 2023, he made the difficult decision to leave his operational role at Depict.ai. He remained a founder and a shareholder, but his daily focus shifted. He teamed up with Fabian Hedden. Hedden was another serial entrepreneur with a deep technical background. They founded Lovable. The name Lovable is an odd choice for a piece of developer infrastructure. Lovable suggests a relationship with software that is not based on frustration. Anyone who has written code knows the feeling of hating the machine. You miss a semicolon and the program crashes. You spend hours hunting for a bug that turns out to be a typo. It is an adversarial relationship. Osika wanted to change the vibe. He wanted to build the last piece of software. The idea is that if you can build a tool that builds any software, then you never need to build another tool. You just ask the tool to build it for you. But the existing tools were not quite there. They were good at writing snippets. You could ask ChatGPT to write a function to sort a list. It would do it perfectly. But you could not ask it to build a competitor to Airbnb. That was too complex. It required multiple files. It required a database. It required a user interface. It required logic that spanned across different parts of the application. This was the problem Lovable set out to solve. They wanted to build a full-stack engineer in a box. Lovable's AI had to do everything. It had to design a beautiful interface. It had to write the logic to make it work. It had to set up the database. And it had to do it all from a simple text prompt. Osika and Hedden built a system that did not just predict the next word. It reasoned about the system. It was understood that if you added a login button on the front end, you needed a user table in the database and an authentication service in the back end. They launched in beta. The growth was explosive. The numbers tell the story of a dam breaking. In the tech startup world, success is often measured in ARR, or annual recurring revenue. This is the amount of money customers commit to paying you per year. It usually takes companies years to reach $1 million in ARR. Lovable hit $1 million almost immediately, then $4 million, then $10 million in 2 months. By mid-2025, they had crossed $100 million in ARR. To put this in perspective, it is the fastest growth in the history of software. It is faster than Slack, faster than Zoom, faster than ChatGPT itself in terms of revenue scaling for a business tool. Investors scrambled to get in. They raised a Series A round led by Accel. They were valued at nearly $2 billion. They became a unicorn, which is the term for a billion-dollar startup. But they did it in 8 months. Startup founders have a term for this new way of working. They call it vibe coding. You say, make the button pop more, make it feel like a luxury brand, give it a retro arcade aesthetic. The AI understands these abstract concepts. It knows what luxury looks like. It translates that vibe into the specific codes and hex color values that the machine requires. This is a democratization of taste. There are millions of people who have great taste but cannot write code. They know what a good app should look like. They know how it should feel. But they were locked out of the creation process because they did not know the syntax of JavaScript. Vibe coding tears down that gate. But most AI models are forgetful. They generate a snippet of code and then move on. Lovable maintains a state. It remembers the whole project. It keeps a mental model of the entire application. This requires sophisticated engineering. It requires managing a large context window. The context window is the amount of text the AI can hold in its working memory at one time. If the code gets too long, the AI forgets the beginning. Osika and his team developed techniques to compress the code, to summarize the important parts, to let the AI focus on the relevant section while keeping the overall architecture in the background. It is a feat of engineering that mirrors the way a human brain works. We do not hold every detail of a problem in our conscious mind at once. We focus on the task at hand while our background knowledge guides us. This is why Lovable feels different. It feels like a collaborator. Anton Osika is a proponent of effective altruism, or EA. Effective altruism is a philosophy that applies the same rigorous scientific thinking to doing good that Osika applies to physics and coding. It asks a simple question: how can I use my resources to save the most lives or reduce the most suffering? Most people give charity based on emotion. They see a picture of a sad puppy and they donate. EA argues this is inefficient. If you have $1,000, should you train a guide dog for a blind person in a rich country, or should you buy mosquito nets that will save the lives of 50 children in a poor country? The utilitarian calculus says you save the 50 children. It is not about what feels good, it is about what is good. Osika has taken the founder's pledge. This is a binding commitment to donate a large portion of his exit proceeds to high-impact charities. He is building wealth to redistribute it where it matters most. Despite leading a company valued at nearly $2 billion, he is said to live in a collective house in Stockholm. This is a communal living arrangement where people share resources and meals. It is a far cry from the gated mansions of Los Altos. He also engages with the darker side of his own creation. He advocates for the safe development of AI. He understands better than most that the technology he is releasing has risks. If AI can write code, it can write viruses. If it can build apps, it can build weapons. The center of gravity for the tech world has always been San Francisco. It is where the money is. It is where the talent is. It is where the vibes are. But Osika is building his empire from Stockholm. Sweden has a remarkable history in tech. It is a small country with a population of 10 million, yet it has produced Spotify. It has produced Minecraft. It has produced Klarna and Skype. It is a factory for unicorns. There are theories about why this is. Some say it is the long winters that keep people indoors at their computers. Some say it is the strong social safety net that allows people to take risks without fear of starving. Some say it is the engineering culture of universities like KTH. Osika is a product of this ecosystem, but he made a choice that shocked many in the industry. When it came time to raise money and scale, Lovable, he said no to Y Combinator. Despite having gone through Y Combinator YC with Depict and understanding its benefits, he was confident that Lovable didn't require it. This decision was bold, an assertion that a European startup could achieve global dominance without seeking validation from Silicon Valley. He is active in promoting European tech. He wants to prove that you can build the fastest-growing company in history from a time zone that is 9 hours ahead of California. Osika sees a future where the phrase "learn to code" is obsolete. In the future, if you have an idea, you are a builder. The friction between thought and reality is reduced to zero. This will release a tidal wave of innovation. We will see apps built by doctors to solve specific problems in their hospitals. We will see educational tools built by teachers who know exactly what their students need. We will see local community networks built by the neighbors who live there. A single human using Lovable can now do the work of a team of 10. This is a 10x leverage. As the AI gets better, this leverage will increase, from 100 times to even 1,000 times. We are approaching a point of singularity in software creation, the point where the only limit to what you can build is how fast you can think.